How did Galileo's telescopic observations prove the heliocentric model? Imagine looking up at the night sky and seeing something that changes everything you thought you knew about our place in the universe. That's exactly what Galileo Galilei did in the early 1600s. Using a telescope he built himself, he made discoveries that challenged the long-held idea that Earth was at the center of everything. His observations helped turn the tide in favor of the heliocentric model, which places the Sun at the center of the solar system. First, Galileo looked at Venus and saw it go through a full set of phases: crescent, gibbous, and full. This was a big deal because, according to the old geocentric model, Venus was supposed to stay between Earth and the Sun, so it could only show crescent and new phases. But Galileo's telescope showed Venus changing shape just like the Moon does, which meant it must orbit the Sun. This directly contradicted the idea that Earth was the center of everything. The only way to explain these phases was if Venus was orbiting the Sun, not Earth. Next, Galileo discovered for moons orbiting Jupiter. These moons are now called the Galilean moons: Io, Europa, Ganymede, and Callisto. This was the first clear evidence that not everything in space revolves around Earth. If moons can orbit another planet, then Earth isn't the only center of celestial motion. This discovery made the idea of a sun-centered system more believable because it showed that other planets could have their own moons, just like Earth does. Both of these observations made it clear that Earth was not the fixed center of the universe. Instead, the Sun was the central body around which planets, including Earth, revolved. This was a huge step forward in science during the time, shifting ideas away from ancient beliefs and toward a model based on real evidence. Galileo's work was a turning point in the history of science. His use of the telescope, a new tool at the time, allowed him to gather facts instead of relying on old ideas. His discoveries laid the foundation for later scientists like Johannes Kepler and Isaac Newton to develop the laws of planetary motion and gravity. These laws are still used today in space exploration and understanding our universe. In the bigger picture, Galileo's observations helped change how humans see their place in the cosmos. His work moved science from speculation to observation, making it a true science based on evidence. His discoveries are some of the earliest and most important milestones in understanding the universe and our solar system.